So we're going to do a brief lesson about the other part when we're talking about three-dimensional shapes. So we've talked about how you basically cover or wrap a shape, right? How much makes up the outside. But next we need to discuss volume! Oh, sorry, wrong kind of volume, right? So when we say volume, we're talking about how loud something is. But no, in this case, I'm talking about volume as how much three-dimensional space a shape takes up. And then you can write that here. And an easy way to think about that is basically like, how big is this in 3 dimensions? In area, we're talking about like how big are the faces in 2 dimensions. Now we're saying how much space in our 3-dimensional world does some object take up? Or, put another way, how much material would it take to make something? To totally fill and make some 3-dimensional shape. That's kind of what we're talking about with volume. Okay?
So it's like volume of the tissue box because of tissues.
Sure, good point, exactly. Volume of a tissue box is basically asking how much tissue fills the box. Or you'll actually see this quite regularly listed on a bottle like this. Because if you're thinking about what this bottle, it's got sort of the surface area of the plastic, right? This is a plastic bottle for hand sanitizer, which is just a shell, right? The outside is just made of plastic. That's kind of the surface area. What really fills this shape is hand sanitizer. And you actually can see that this can hold 1 liter. The capacity is 1 liter. Now, right now, the volume is less than that, right? It's not full. Maybe there's like 300 milliliters or something like that. It's not totally full. But it can take 1 liter. The volume that this shape can hold, the capacity of this shape is 1 liter. Okay, hear how I'm using these words?
So wait, how did they fit? We could figure out how they did the equation by, I guess, dividing 1 liter by how it like a quarter, I guess.
Yeah, let's wait a minute before we get there. I'll talk to you about how we get to each of these. But at its core, the way we think about volume is basically what's the area of some layer of it, and then how many layers are there, especially the prism, right? If it
Go back real quick.
yeah, made it 10 minutes to your class, very impressive.
I got here with like a minute left.
So in this case, it's like you can kind of say, okay, how big is this circle on the bottom, and then like how many layers of that are there? We've probably all done this before when thinking about like cube links and stuff. Let's go to that situation with a simple rectangular prism to start. So. Oh, and you can fill in a few spots where you use volume in everyday life if you like. Filling up a object, finding how much material is needed for something.
Glasses.
Sure. So let's think about this. So I have a 3-dimensional rectangular prism here, made of cubes, and this is a 6 long and 4 wide. And then it's 2 layers tall. So this one has 6 centimeter cubes, 4 centimeter cubes, and then 2 centimeter cubes high. Yeah. Now, before we worry too much about volume, let's think about how we find just the area of the base. So this bottom layer, what's the area of this? Well, it looks like it's a 6 by 4 rectangle. Or we could say it's 24 square centimeters. Right, there's like 24 squares along the bottom. And if we were asking about volume here, we could say, oh, it's like 24 cubic centimeters along this layer.
Wait, 4 times 2 then, right?
Yeah, so exactly, to find then the total rectangular prism, it was 24 to make up that bottom layer. There are 2 of those. So there's 48, and we can call these centimeter cubes, or centimeters cubed. Right? Symbol is squared, symbol is cubed. All that this one means is centimeter times centimeter. So all this one means is centimeter times centimeter times centimeter. It's 3-dimensional centimeters. Right? Bonk, bonk, bonk. Okay, so starting off, we noticed somehow the relationship between area of the bottom and total volume is like area of the bottom times the height. And this, by the way, is going to be a really key thing with any prism. If you can find the area of the base and multiply it by the height, you'll have one.
Interesting.
Okay, how about this rectangular prism? So now we have just a 3 by 2 rectangle on the bottom, but there's 8 layers of that. So the area of the bottom is 2 by 3, or 3 by 2.
6 times 8.
So 6 centimeters squared. Yeah, exactly. So then 6 by 8 is 48 cubic centimeters. How many cubes are needed? 48 of them. Okay, looking at this, who's like, oh yeah, I've done volume of prisms. Right.
How many layers there are, though? That's the
It,
big
it told us here.
Right,
I
okay.
would say, yeah. I can see that if you're trying to count it, you would be able to see, but it didn't tell you that height was 8. Let's see. So, in this general case, what formula were we using for the volume of a rectangular prism? Yeah, exactly. The way we did it, we went length times width, and then we went times height. But right, length times width times height. You have to do 2 separate steps. Now I kind of like this because let's take a look at it. I noticed that there's tank 3, which is smaller than tank 2, which is smaller than tank 1. And if I took tank 3 and I put one of them beside the next one, is it true to say that tank 2 would basically be tank 3 beside tank 3? 20, 20.
20, 40, 20, 60, 20.
Right, because if this is 20 high and 20 deep, then the only thing that's different is the base, 40 and 20. So if I just put this one beside this one, it's like there's 2 20 by 20 by 20 cubes beside each other. And similarly, I actually think tank 1 is like that, except split in 3, right? 20, 20. So I'm curious to see if this is true in terms of volume. I'm suspecting that tank 2 should be double tank 3, and that tank 1 should be triple tank 3. So I suspect. Let's see if that's true. How much water will be needed for each? Well, let's see. So tank 1, or I could say volume of 1 equals 20 centimeters times 20 centimeters times 60 centimeters. Maybe I should have done 60 times 20 times 20, whatever. The volume of 2 will be 20, 40, 20. And the volume of 3 is going to be 20, 20, 20. Yeah? Length times width times height, length times width times height, length times width times height. So that one is 8,000 centimeters cubed. This one is 16,000 centimeters cubed. This one is 24,000 centimeters cubed. By the way, if you're wondering, hey, how do you multiply big numbers like this in your head when they're just multiples of 10? Well, 2 times 2 times 2, 8, with 1, 2, 3 zeros. Or this one, 2 times 4 times 2, 16, with 1, 2, 3 zeros.
So that's the amount of water.
Yeah, exactly. That's how much water could fill the tank. Cubic centimeters. And we're going to talk down here about how cubic centimeters and liters are related. And by the way, I kind of mentioned B already. Tanks 2 and 3. Tank 2 is double tank 3. You can see, right? And tank 1 is triple tank 3. And you can even just see it by saying, like, I took this and fill it there, fill it there, fill it there, fill it there, fill it there. I find visually that's what helpful.
Yeah.
So now if I'm going to C, 1 liter of water is 1,000 centimeters cubed. How would I convert these numbers into liters?
B. We didn't. Or did we do B?
I'm just saying B. We already talked about that. It's double, right? It's double
Oh,
minus triple. So on C, how do we convert 1,000 centimeters cubed to liters? Let's do the math here for this first one. Right, we have 24,000 centimeters cubed. And if we use our dimensional analysis, so times 1 liter per 1,000 centimeters cubed, we realize, oh, it ends up just being centimeters divided by centimeters. So we go 24,000 times 1 divided by 1,000. That's 24 liters. So it ended up being just divided by 1,000. So we can do the same thing for these next ones. 16,000 divided by 1,000 is 16 liters. And 8,000 divided by 1,000 is 8 liters. So our three values are 24 liters, 16 liters, and 8 liters. 24 liter tank, 16 liter tank, and 8 liter tank. And if we're trying to think about sizes, this is a 1 liter bottle. So the first fish tank is like 8 of these.
Interesting. That's a very big fish tank.
Pretty small, pretty small. You would not want to put very many fish in it. Because if you're thinking about sizes, this was saying 20 centimeters by 20 centimeters by 20 centimeters, right? This is 30 centimeters. A foot is 30 centimeters. So we're basically saying a fish tank is like this by this by this. Not very big.
Can't hold 8 liters, can it?
Yeah, that's interesting. Interesting. That's 8 liters.
Oh, it doesn't. It doesn't really look like it.
Doesn't quite look like it, eh? Big thing is width there.
Mm.
Yeah. Thank you. Alright, how about a cylinder? So I've just shown you this picture of a cylinder. If we're saying the volume of a prism is the area of the base times its height, the area of the shape on the base times its height, so the volume of a prism in general is equal to area of the base times the height of the prism. How would I find the area of the base? Noticing that the base here is a circle. Area of a circle. We might have done this a few times yesterday. Yeah, pi r squared. Nice. So in this case, area of a circle is pi r squared, and then times the height of the cylinder. So the volume of a cylinder is pi r squared times the height. And if you look on the formula sheet at the back of your book, that's what it'll say for volume of a cylinder. It's pi r squared times height. It's not pi r2, it's pi r squared. Very different, right? Pi r times 2 or pi r times itself.
Yeah, pi r2.
It'd be the same if it's it would be the same if the radius is 2 though.
Pi r2 would be 2 or it's squared smaller above.
Okay, so how about this climbing wall grip? Climbing wall grip. So it's saying this one is a cylindrical grip with a radius of 1.5 inches and a height of 3 inches. I was just saying the volume of a cylinder is equal to pi times radius squared times height. So I'm wondering about volume, radius, and height. Well, volume I don't know. Radius is 1.5 inches. And height is 3 inches. So now I can sub in. Volume equals pi times 1.5 squared times 3. Take the numbers that I have, substitute into the formula. 1.5 squared is 2.25 times 3 times pi. We get 21.2. Right, there's 10, 21.2. And my units, if you're ever wondering units, let's think what was in this initially. Inch times inch times inch. Inches.
So that's our.
Volume is 21.2 cubic inches. Inches times inches times inches. Inch. Interesting. Boo! Get off the stage! Alright.
Honestly.
How about this? Now, this is gonna take us a bit of work. This is gonna take us a bit of work. We have a challenge question. We're going to try attacking it together. I think this one I'm going to just do with you. So before we start here, let's just visualize we have. We have this nice, solid piece of wood, but with like a tunnel through the middle, a hole through the middle, which is empty, right? It's full of air.
Projector, basically.
For sure, sure. So we're asked two things. We're asked go back to yesterday and find the surface area, and then we're asked to do what we're doing today and find the volume. Okay, so first of all, surface area, we always just add up the area of all the surfaces. So let's figure out all the surfaces. Well, there's a top and bottom, 1 and 2. There's a side, another side, 3 and 4. Now, 5 and 6 are a little bit interesting, right? They're like a rectangle with a rectangle removed from the middle. And then if I was thinking about all the things touching air, there's also these inside pieces. There's also like 7, 8, 9, and 10. There's like the inside of the tunnel. So I actually have 10 faces to find here, a bunch of which are pretty easy. They're all rectangles, except 5 and 6 are a rectangle with a rectangular roof. So I won't need to do too much drawing. I'll probably draw shapes 5 and 6, but I won't do the rest. So I know here that surface area is going to be area of 1 plus area of 2, plus area of 3, area of 4, 5. I'll probably need to use the other side here, plus area of 6, area of 7, 8, area of 9, plus area of 10. Right, I'm just adding up all of these areas, and I'm going to get some value at the end. Now, these are all rectangles. 2 of them are going to be rectangles with a rectangular move, but they're all just rectangles. So length times width. So for 1, it's a 5 by 7 rectangle, which is 35 centimeters squared. 2 is the same, 35 centimeters squared. Oh, I just 3 and 4, didn't I? I just 3 and 4. Sorry, guys.
Oh, shoot.
Let's just renumber these because Mr. Boyce is in the end. Sorry. So there's 1 and 2. I started from the sides to the top and bottom. No big deal, I guess. Oh no, no. You guys, I'm correcting myself when I was perfectly fine.
Second guess yourself.
Yeah, second guessing myself. I guess we all know about that, eh?
Yep.
Okay, so it looks like 1 and 2 were 5 by 7. Yeah, that's fine. So now it's 3 and 4 are the sides. Yeah, they're the 3 by 7s. 3 times 7 is 21. 21 centimeters squared. Okay, I'm going to just leave 5 and 6 for now. We'll need to come back to them. They're a little bit uglier. So it's 7, 8, 9, and 10. These are the inside ones, inside rectangles. So they're still going to be length times width. Let's see, 7, that's like this inside wall. It's 0.5 tall by 7 centimeters deep. 0.5 times 7, that's 3.5 centimeters squared. And 8 is the same, 3.5 centimeters squared. And then it looks to me like 9 and 10, they're the top and bottom on the inside. So that's like 1 centimeter by 7 centimeters deep. 7 square centimeters. That's 7 square centimeters. Okay, so I've got all of my areas except this front and back one. And why don't I just draw this front for a second so we can visualize what we're trying to deal with here.
Is that 1.7 or 1 times 7?
That was 1 times 7, which ends up being 7. That's the one downside of using dots, eh? Is that it sometimes makes up for us. Okay, so this is this front, and the back will be the same. And this is a 5 by 3 rectangle, but there's a 1 by 0.5 hole in it. So I'm going to need to go length times width of the big part minus length times width of the little part. Yeah, it's like the part that I have minus the hole in the middle. Or I could say it's 5 times 3. Don't fail me now, pen. 5 times 3 minus 1 times 0.5.
Minus 1 times 0.5.
Or we could say 15 minus 0.5. Okay, area 5 is 14.5. Oh, I barely ended up removing anything, hey? I just ended up removing a half of a square centimeter. Which is right. 1 times 0.5 is a half. And fortunately, area 6 is the same. So that's 14.5. And this kind of shows what I was talking about a couple days ago. It's not that any of the individual steps of surface area is hard. But I think finding the surface area is much, much harder than finding the volume. There's a lot more steps. You have to be a lot more organized and a lot more aware of what's happening. Yep. So in this case, there were 10 things that I had to find. I found all 10 faces. Well, now it's 7. How's that? So I have 35 plus 35 plus 21 plus 21 plus 14.5 plus 14.5 plus 3.5 plus 3.5 plus 7 plus 7. So I end up with 162 meters squared. Right, by adding up all 10 of these values, boom, 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 I have the area of all the faces, and I find the surface area of the wood. Outside face of the wood. Tough one, tough one. There's a reason it says challenge. I'll wait for one back. Oh yeah. Okay, now I think you'll probably appreciate doing the volume instead. For most of us, this next step is actually not quite as tough, right, Evan? What are you nodding your head? That's like the thing my mom used to say. If your friend said to jump off a bridge, would you say okay? I said it depends how high the bridge is. All right. How about this volume? Now, volume of a rectangular prism is pretty simple, but let's just think of what's happening. So this one, we're talking about how much tissue can fill up this box, how much stuff makes up this thing, except there's a hole in the middle. Hole in the middle that's not full. So it's like we need to do the whole rectangular prism minus this other rectangular prism. Yeah? And I've seen people before, by the way, try to break this into like a bunch of smaller rectangular prisms and find all of them. I'll show you something easier. Let's just take out the negative space. So we're going to say volume of this whole thing, or maybe volume total, equals, this will be really precise, volume of the big one minus volume of the small one. Yeah? Volume big minus volume small. Nice and precise here. And they're both rectangular prisms. So we end up with length times width times height minus the smaller length times width times height. So for the large rectangle, it's length times width times height. Exactly. 5 times 7 times 3. Minus the volume of the smaller one is 0.5 times 1 times 70. So we end up with 35 times 3 minus. So once again, the whole is a very small part proportionally, but it is part of it. This ends up being 101.5 cubic centimeters.
So our answer is 101.5.
Yeah, 101.5 centimeters. Bit of a beast. Also eminently achievable. We can do that.
So far we did this. Interesting.
And I'll bring you back to a moment in your life you probably really loved. When you guys were in grade 9, there would have been a question very similar to this in the grade 9 PhD.
Didn't do it.
Didn't
get grade 9 cakes.
Well, you get to do it. Now you're getting to experience it in this case.
No.
Okay.
I wasn't stressed with this.
Okay, nice. Well, you're learning.
I panicked and circled and stuff.
Yeah, fair enough.
Because my mom forced
A, C, D, C, A, C, D, C.
It was so I think it's so my teacher was like, you literally put 9 on the answers. I was like, I don't care.
All right. Next one. This is not a challenge problem. We should be able to do this one. We should be able to use our volume of a cylinder to attack this one. It asks about quantity of water. That's a volume. So volume of a cylinder is pi r squared times height. Okay, so we're looking for volume. Don't know how much. We have radius. Wait, do we? Have diameter. Okay. Right, 7.5 over 2, or 3.75.
Is that a question mark after the second volume? What was that
Well,
second box?
sometimes a 2 feels like a question mark, doesn't it?
That's a 7, yes. The one, not the top volume, but the volume below the top volume.
Oh, wait, that is question mark.
Okay.
Alright. I see what you're saying.
I got confused.
Wait, this is getting worse, Mr. Boyce. Question mark. Now, Gabe, can you read that?
Thank you.
The Riddler, if you please, with that one.
Yeah,
Okay, and now the depth is 2.3. My listing variables made us more confused. Great. Okay, so volume is pi times radius here is 3.75. The most common mistake on one like this would just be to forget that the diameter is not the radius, right? You have to divide by 2. And then times depth, 2.3. How do I put this in my calculator? I go pi times 3.75. It's the part that's squared, it's not pi times 3.75 all squared. It's pi times just 3.75 squared times 2.3. So volume equals 101 point, okay, nearest tenth, 610, blah, blah, blah. Okay, so I'll call it 0.6. And that is in meters cubed. 101.6 meters cubed.
That's confusing, the brackets. Just easier than putting in a time symbol on there.
Yeah, you've probably noticed that when I use dots or when I use X's, there's lots of things to mix it up for. So once you get into especially substitution, you'll almost always just see parentheses used to kind of show what you're multiplying. That'll be the most common syntax.
Brackets confused me briefly.
Now, you do have some time to practice today. I'm guessing question 1, probably pretty straightforward. On question 2 and on question 3, if you'd like some support, feel free to chat with your friend. Just pick your friend who's the smartest one. I think you guys got this. Yes, Henry? Yeah. Thanks for your patience. Okay, good. Go for it. How's that look? Maybe go back and just check the surface area stuff and see what we got.